Good morning to one and all. This is Dr. Madhuri, Professor of Physics in Vignan's Foundation for Science, Technology and Research University. Today we are going to start our journey to learn about one of the outstanding inventions of 20th century. I'll give you a clue to guess what we are going to learn. In physics, the Nobel Prize was awarded in 2018 for groundbreaking inventions in this field. If you still not guess, let's have a look at the video so that you can easily guess what we are going to learn. So let's have a look at the video.
The feel for darkness is vanished when man discovered fire. Till then, man knew only natural sources of light. Later, light source evolved into different artificial forms to make human life more cozy. Subsequently, physicists put their effort to develop devices for producing powerful beam of light, which resulted in the invention of laser.
Yes, students, you are right that we are going to learn about lasers in today's session. What are today's objectives? Let's move on to objectives first. The first objective is what for lasers? Why we need to learn about lasers? Where we are using these lasers in our daily life. Once if you know that it has more applications for society and industry, let's look into what is laser and is it really different from normal light? If so, what makes it differ from normal light? And what is the basic principle involved in it? And what happens if radiation interacts with matter? In addition to that, why we are using only stimulated emission in case of amplification process in lasers? Let's look into our objectives once again. What for lasers? What is laser? And if it really different light, what makes the difference between normal light to laser light? What is the principle involved in this? And what happens if radiation interacts with the matter? And why we are using only stimulated emission for amplification process in the lasers? Let's move on to applications of lasers in everyday life. So look at this. We are using these lasers in laser printers and laser pointers. In addition to these commercial applications, we also use these lasers in material processing. That means in cutting of hard materials and drilling of hard materials, not only in industrial applications. We also use these lasers in medical applications such as retina reattachment and removal of tattoos. So we cannot confine the lasers only with these applications. Laser is a high technology device which covers commercial to industrial applications.
Few more real-world applications of laser are laser photogrammetry, which is used for measuring the size of the large animals and water without physically taking them out. Lasers take a vital role in astronomy. This is the sodium laser, which is being used to create guide stars and getting a clear picture to know about what's beyond atmosphere. Lasers are also used in satellites, stargazing, and pointing out different constellations in the sky. Move on to laser level tool, which is used to create more accurate level and for other applications in construction. In addition to the eye surgery, lasers are also used in dentistry, skincare, and several scanners. Lasers are used in optical fibers for data transfer and communication purposes. I'm pretty sure that all of you know about laser tags, which are often used in playing games. Lasers are also used for manipulation of materials like greening, welding, drilling, moving rust, etc., where high power lasers are used. Move on to military weapons, which are used to shoot down missile planes of enemies. Here also we are using high power lasers. Lasers are used in disk drives like DVDs, CDs, in which a small laser diode is placed for their operation. In agriculture, lasers are used by farmers for bird deterrent so that the birds get scared to come to their crops. Next important application is optical tweezers. This is the area that Nobel Prize 2018 in physics was awarded. Lasers are also in gun sights, barcode scanners, printers, and also used in laser shows.
Hence, we can say laser is a milestone in engineering and science. For each invention, there is history. Let's have a look into invention of laser. In 1916, Einstein predicted about the stimulated emission, which is the theoretical basis for laser. With this theoretical basis, in 1954, C.H. Towns and Group developed Laser. This is the practical orientation of theoretical basis given by Einstein. Laser is nothing but microwave amplifier by stimulated emission of radiation. This theory extended to light in 1958, and in 1960 the first laser was developed by Mike. In 1961, first gas laser was developed by Ali Jawan, which gives more commercial applications, followed by there are so many powerful lasers was developed which can have industrial applications. Let's move on to what is laser. What is the acronym of laser? Laser is light amplification by stimulated emission of radiation. This is the acronym of laser. The meaning of this is you are going to amplify the light by stimulated emission. Let's have a question now. You are saying that light is amplified. That means is laser is an amplifier or generator. So you could say it's not only simply an amplifier, but it also generates light. So laser is a generator of light also. Now, if it has covering several applications in daily life, what makes the difference between ordinary light and laser light? First, imagine one laser pointer. So you can see only one color. That means it produces only one wavelength. Hence, we can say the laser is monochromatic. But from our childhood onwards, we know that ordinary light consists of VIBGR. That means many colors. Hence, ordinary light is polychromatic light. When it has only one color, it is traveling in the same direction. So, you can say that it has high directionality. When it has high directionality and it is concentrating at one point, you can say that it is highly intensified light. When it has high intensity, you can say that it is having high energy. In addition to the high energy, high directionality, you can also characterize characterize this laser with polarization. So, laser is polarized light. So, it can eliminate all other directions and it can move only in a single direction. So, you can also tell that one of the characteristics of laser is polarized. In addition to these basic characteristics, the important characteristic of laser is coherent. Laser produces coherent beam of light. Let us see what is the phenomena of coherence. So look at this picture where you could see three different diagrams. In the first figure, that is in figure A, you are using normal white light source which is polychromatic. You already know that. That's why the emitted radiation can give different wavelengths. How I can say that it is producing different wavelengths? So the representation is with the three different colors. So the waves are having various wavelengths and they are traveling in various phases. Coming to the figure B, we are using monochromatic light. So where it generates a single wavelength. So in the diagram you can see the difference from the first figure that all three waves are having the same green color. So the waves are producing from monochromatic which contributes the same wavelength, but the waves are not traveling in the same phase. Coming to the figure C, which is from laser light source. The waves are from laser light source. If you could see the waves emitting from the laser light source, all the waves are having same wavelength, same frequency and also maintains the same phase or constant phase difference. This phenomena is known as coherence. So I repeat, when you are talking about the coherent radiation, the waves should have the same wavelength or frequency and they have to maintain the same phase or constant phase difference. We are all familiar that when light radiation travels through the medium, it undergoes absorption or scattering processes. Is it really possible? Yes, it's quite impossible when you are thinking in the view of classical mechanics, but it is possible in view of quantum mechanics. If that is the case, when radiation is traveling through the matter, what are the various kinds of processes that we could expect we are going to see? So look at this picture. Matter, that means which consists of atoms. The atoms are represented knots. And we are considering the ground state atom as A. When it is excited to the higher energy state, we are representing it as A star. And the radiation we are representing with a waveform. And the energy of that radiation is h nu. What happens if this radiation interacts with the material or matter? One can expect three different kinds of processes when you are considering the interaction of radiation with the matter. First one is absorption. You can also call this as induced absorption, spontaneous emission, followed by stimulated emission. Now this is very important to understand the laser processing because we are going to use this stimulated emission in case of amplification of light in the laser. Let's move on to absorption. Here you could see two energy levels and A is the atom which is in the ground state. The material is consisting of atoms which are identical and each atom can be characterized by its energy levels. There are n number of energy levels for each atom. For our simplicity, I am considering only two energy levels, out of which E1 is the lower energy state or ground state and E2 is the excited state. When you supply the energy which is equal to the difference in the energy levels, that means E2 minus E1, the photon from the radiation absorbed by the atom and the atom get excited to the higher energy level. This phenomena is known as absorption. If you are not supplying any kind of energy, the ground state atom still remains in the ground state. So, if you supply the energy, if it will get absorbed by the atom, then only the excitation process or the phenomena of absorption occurs. Hence, we are also call this process as stimulated absorption. Mathematically, we can represent this equation as A plus h nu, where A is the atom in the ground state. We are supplying the h nu energy, it absorbs energy and get excited to the higher energy state, which is A star. What happens after it gets excited to the higher energy level? Each atom can stay in the higher energy state only up to its lifetime. After its lifetime, it automatically goes down by releasing the same energy h nu so that the atom goes to the ground state. I repeat, in case of spontaneous emission, the atom at first is in the excited state. So look at this equation. A star, the atom is in the excited state. When it automatically goes to ground state after its lifetime, it emits a photon A plus h nu. The two important words in spontaneous emission are the process is spontaneous by itself. It's random. So we are not supplying, we are not stopping this process. So spontaneous emission is random process. If I have 10 atoms in the higher energy state, they can go down immediately after finishing of their lifetimes. But it's not sure that all emitted photons are with the same phase. So it's a random process where this emission emits energy or emits photons which are incoherent. Hence, we cannot use this energy in case of amplification process. Then how we can make this emitted photons into coherent? For that, we are moving to stimulated emission. In case of stimulated emission, within its lifetime, one more photon is triggered with the atom with the excited state so that it pushes the atom to down or ground state so that the two photons will come out within the same phase. That means the emitted photons are coherent. I repeat, to make the emitted radiation coherent, we are triggering the excited atom with one more photon within its lifetime so that this photon pushes the atom down and two photons get out at the same time with the same phase. Mathematically, you can represent A star, that is atom in the excited state. You are giving energy plus h nu gives rise to A plus 2h nu. That 2h nu is the emitted coherent photon. The three important words here are the process is within lifetime, and the second point is you need to supply the energy within its lifetime, and whatever the emission of the photons in this process are coherent. If I don't supply any energy for the atom which is in the excited state, there is no stimulated emission. So you can say that it's not a random process. And The emitted photons are coherent in nature, hence we can use this in the amplification process. By knowing these definitions, let us consolidate the two emission process and the difference between the two processes. The first difference is, in case of stimulated emission, the emitted photons are coherent. Hence, we can use this coherent radiation for the amplification process. And when you are using this in the amplification process, you can say that this releases a high intensity, high directionality, and the process can be controlled from the outside. Whereas in spontaneous emission, the emitted photons are not coherent, hence you cannot use this in the amplification process, and all the emitted photons are randomly moving. That means it's incoherent. We cannot control it from the outside. The example for stimulated emission is any light which is emitted from the laser source, whereas for spontaneous emission, the example is light from sodium or mercury lamp. Let us consolidate or summarize the whole session. We are learning here the laser. The acronym of laser is light amplification by stimulated emission of radiation. As we know that the laser has wide applications, the important characteristic of laser are monochromatic, coherent, highly intensive, and high energetic radiation. To achieve this laser light, we are using the process called stimulated emission. The stimulated emission emits the photons within its lifetime by triggering with another extra photon when it is in the excited state. With these basic fundamentals, we are going to stop this session, and the coming session you are going to learn what are the basic components of laser to construct any kind of laser, and how lasing action takes place, and can we classify the lasers? If so, what are the basic parameters to classify? Out of various lasers, we are going to look into one of the gas lasers, and the construction, working, and applications of one of the gas laser we are going to discuss in the coming session. Thank you.